This is question number 3 from June 13's SS05 paper. It's a question that combines checking for equity of standard deviations, and as we move on into part B, checking for equity of mean yields. We're given information about two tomato yields with different fertilizers. We have 10 items, I think it is, from Mortom, which is one of the brands of fertilizer, and 8 from Tom Plus. We start the question part A. It asks us to show, using the 5% significance level, that there's no difference in variability between the yields from plants grown using Mortom and the yields from plants grown using Tom's Plus. This is a very common start to a question like this, where we're asked in the first instance to check the variability, and then we use that moving on into the second part B here. I've started by setting up my null and alternative hypothesis. I've used sigma subscript m for Mortom and sigma subscript t for Tom's Plus. This is then a not equal to situation, because they've just asked us to check whether there is a difference. Hence it's a two-tailed test with 5%. These could equally be written in terms of the variance, and I could have a square on all of these, and that's equally acceptable. What I've then done is I've calculated, using my calculator standard deviation function, I've worked out the standard deviation for Tom's Plus and for Mortom, and found that the Mortom value was bigger. If you remember, when we're testing for variability here, we're going to use an F test, and we use an F test statistic. And the method that we adopt here is to put the bigger of the two values that we get on the top and the smaller on the bottom, and we do this in variance form. And dividing 18.4 squared by 17.8 squared gives me 1.07. The reason that we always pick the biggest value on the top is because then we can use the upper tail significance in the table, and it makes our life easier. The significance level is 5%, and it's two-tail, and I find that information from table 7 in the formula books. I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, as I've said, for Mortom, and 8 values for Tom's Plus. So with my degrees of freedom, I look in the table at 9 and 7, and my value that I get there is 4.823, which I've taken down there as my critical value. So here's my diagram that I've drawn. My test statistic was 1.07, and you can clearly see that doesn't lie in the critical region. Hence my conclusion is that we'll accept H0 and conclude that there's no difference in the variability between the tomatoes. Moving on to part B, we're asked to investigate at the 1% significance level that the claim that the mean yield from plants grown using Mortom is greater than that from plants grown using Tom's Plus. 10 marks are available for this question, so a really important one. Because we accepted H0 in the first part A, we can use the standard deviations in our calculation. This time again, for our null and alternative hypothesis, our null hypothesis is the mean for Mortom is equal to the mean for Tom's Plus. But in this one, we were asked to check whether Mortom actually increased the yield. So it's a one-tailed test and 1% level of significance. What we need to do now, in order to carry out this test, is to calculate a pooled variance. We do this by using a formula that's available in the formula book. It's quite a meaty formula, but as I say, it's available to you. And I've substituted in my numbers 7 lots of 17 minus 8 squared plus 9 lots of 18 minus 4 squared, 18 minus 2, and that gives me a pooled variance of 329. Then my formula for my test statistic here is the mean that I've got for Mortom, take away the mean that I've got for Tom's Plus, and again I've calculated both of those values, over my pooled variance multiplied by 1 over n and 1 over m. Again, this formula is given in a certain form in the formula book, and I've substituted in my value here, but again they're really well explained in the AQA textbook, and that gives me a test statistic of 4.101. The critical value for this is 2.583, and I get that from t-tables, going back to what I've had before, one tail and 1% level. On that basis, 4.101 lies in the critical region, and I subsequently reject H0. and conclude that there is evidence that the mean for Mortom is greater than that of Tom's Plus. And that, in accumulation there, would be worth 10 marks. The final part of the question gives me the cost for plants. For Mortom, 10 plants were £15, and for Tom's Plus, 8 plants was £10, or were £10. Thomas sells all his cherry tomatoes at £3 per kilogram, regardless of whether they were bought or made with Mortom or Tom's Plus. And we're asked to use this information together with your findings in Part B to advise Thomas on which of the 2 brands of fertiliser he should use next season in order to maximise his profit per plant. What I've done here is I've worked out a value here of £1.25, which is the cost per tomato plant for Tom's Plus. So I was told that 8 plants cost £10, in which case you can work out the individual cost, and I've done the same for Mortom. They cost me £1.50. So whilst yes, they're yielding a higher amount, they do cost more. So the means that I had before, up here I had 1377. If I convert that into pounds, sorry, I'll follow that one over here. If I'm making £3 per value there, this is the amount that I'm going to be selling. On average, I'm going to be getting £4.13 income for those, and for the Tom's Plus, £3 multiplied by 1.342 is going to give me a value there of 4.03. I've then calculated the profits of each of those. So the expected income is £4.03. Tom's Plus plants cost me £1.25 each, so my expected profit for Tom's Plus is £2.78. If I compare that with Mortom, the expected income there is £4.13. My plants cost me £1.50. The profit expected there is £2.63. So the advice that I would give to Thomas is that Tom's Plus, although not yielding quite as much, the expected profit is greater using that tomato plant.